Yeah, welcome to my talk now. And disclaimer at the beginning, it will get a bit technical. Even though we are in the business models track, we will talking tech. Not too much, but quite a bit. And that's because I'm a techie myself. I'm a developer and architect at Pentacor, working in Chemnitz, Germany. We are an IT consulting company offering IT architecture services, architecture consulting, and software architecture. We build cloud-native software, and we deal a lot with APIs and data products. And that's what I brought for you today. So we will be talking about data. And we will be talking about the roads in Sweden in some way. This year is very special for me. It marks 10 years of traveling to Sweden, so I saw quite a few of the roads in Sweden. I really like them. And yeah, actually it's the third time this year that I'm in Sweden. And on Friday I was in Gothenburg and saw roads that looked like this. So they might need some kind of maintenance. We have a few potholes and cracks, and yeah, probably want to do something about that. And that will be sort of the frame for the talk today. So we will be talking about data and people, and yeah, what is this all about? If we think about data in IT systems, it usually looks like this. We have data in some data store, and we have a system and a service in that system that accesses that data. And so the data in that data store is directly associated with the service in some way. Maybe in our system A, there also is another service A that also wants to use that data. So maybe ask service A1 to say, hey, I need your data, please give me your data. We might have some internal APIs there. Another service, A3, within the same system, might make use of the same data store. That's sometimes some architecture style that we don't really like. We say, microservices, no, every service should have their own database, and we don't want to share that, that's bad, and yeah, don't do that. And that's particularly relevant if we think about the system as a whole, and we have a team A maintaining that entire thing, all the services and the data store, and certainly they want to keep their data private. It's their data, they don't want to share it, they don't want to have everyone use that just as it is there. So if there is some service B in some other system maintained by team B, and they want to use the data, they have to use an API provided by system A, of course. That's what we probably all do if we build systems. That's how we build systems for quite a long time. So in the end, our data in the data store A is hidden. But actually, we saw that there are quite a few parties that are interested in the data in the end. So data is a valuable resource in companies, and it plays a central role since different teams want to play with that data, and they have the specific scenarios. And if we think about the roads in Sweden, and not just in Sweden, we can think about the data as sensor data captured by vehicles, because there are a lot of vehicles passing by the streets, and they probably know quite a bit of the data there. And the data that's captured is owned by some team within the company. And if we think about our example, that could be some research and development department that does something with that data, does some calculations, for instance, takes the sensor data input and calculates what is a crack in the road surface and what is a pothole, and that data is then stored in some data platform storage. It's progressing more than I want. And the example here could be the Microsoft Azure data platform. And if we think about the data as a resource or the data as a product, then we would be packaging all that together. We have the data, the ownership, and the technical representation where the data is stored, and we treat that as one product as a whole. And we just heard a nice way to describe products and how to monetize them in the end. So we could define a product, surface events, that describes the state of the roads in Sweden, for instance, and that is designed for a very specific use case. And in that case, this use case is the status quo of the road surface. And this data could be made available to other teams within the company, or maybe outside, but we will get to that. And because we are about to leave the context of our team, of the team that owns the data, that is very familiar with the data, that does all the calculations and the processing, we need to describe the data in some way so that others can make sense of it. And here, data contract comes into play. And that is sort of the documentation of an API. Or if you compare it to an API, the Open API spec would be the documentation of the API, or the API product, and the data contract is the specification, documentation of the data product. The data product itself is actually a logical unit that is just designed to process, store, and provide domain-specific data that can be made available to others. And the data contract then describes exactly that. So we know or get to know who owns the data. We have some information about the terms and conditions to use the data. We get to know the data model. We have some example data in there maybe, or some quality criteria that can even be executed so that we get a feeling for the data we get. We find SLAs in the data contract, and we also know how we can actually get that data. So we find the servers in the data contract. But all of that seems to be very specific to the internal use, because if we think about the service, we might not want to get others access to that. So yeah, I always said that. So if we look at the overall picture, we have many, many data products within our company. They are all stored within a common data platform, and all that is only accessible to the individual teams within our company. So if we want to change something about that, we need to look at the bigger picture. The internal teams don't have an issue because they are within our company, they have access to the data platform, they can take a look at the data contract, so they know what they're dealing with and they can make use of that. Because within the company, we most likely don't have an issue granting them access to our data platform. But if we look at the externals of in the world, so the general public, then we probably don't want them to just access our data platform. We don't want to share the access to our SQL databases or S3 buckets or whatsoever. That might be a bit weird to do that. So we need some other way to grant them access, because they might also have use cases, and road authorities, for instance, might be interested in road surface conditions, so they want to monitor that, and maybe they even want to pay for that. And that's where APIs come into play. But if we think about APIs and the way we use APIs to, not too fast, how we use APIs to grant access to data, we usually build integration layers, we build special services that integrate a data platform and do that for all the APIs and for all the data products, and we saw we have quite a few of them, so we need some way to do that efficiently. And for that, we take another look at our big picture again. If we think about what we actually need to build, we see two sides of this API puzzle in the end. On the one hand, we have very specific things that are specific to each data product. We need special configuration, we have a dedicated data model, the schema is different, we might have different filter criteria in all the different products, and that needs to be defined for each product individually. But on the other hand, there also is stuff like data export functionality. We know that we need to have some kind of search and filter in place in general. We need to have identity and access management. We want to have multi-tenancy because the road authorities in Sweden maybe are interested in the road conditions in Sweden, but we probably don't want to tell them about the road conditions in Germany, or they would have to pay extra for that. But I think having no interest in that is more relevant or more likely. So multi-tenancy is the thing, and monitoring is the thing, and monetization actually is not even included here, but plays a role as well. So there is a lot of redundancy in the requirements that we have. So that gives some potential to abstract and generalize the picture. And one part can be provided by API management, which is a central resource in the end. And on the other hand, we might use some shared implementation that can be abstract. And if we think about the API management, it provides things like identity and access management, multi-tenancy, we get the monitoring there, we can also use it for monetization. And if we think about the actual implementation of the API backend services, we can have a general implementation of search and filter there, of the data export, of the integration of the data platform itself, and that might even come with some reasonable default configuration so that we, for each API on top of that, only need to add a very thin layer that defines the specifics of each and every API for the data products. So we have a common foundation to build on, and we set up a very specific extension for each of that. And now it gets more technical. How can we do that? That was intended to progress on click. We leave it like this. Or I don't touch the clicker, maybe. We can make use of the OpenAPI specification itself because OpenAPI has a concept of extensions, and with an OpenAPI extension, you can see it as a x minus something, we can put whatever parameters we want into our specification. And together with some templating, we can define any information that we don't already have in the spec itself to then generate the code that we will need for our implementation in the end. And in this example, we are using Maven to build a Java application in the end. With that, we have mainly the spec that we need to customize for each and every product. And with that, we again have our common baseline with the default properties. We have the OpenAI specification that defines the hard-coded static parameters that we need for the different products. And in this example, talking about a Java application, so we might have a Spring application with some configuration. There we also have some configuration that can go into the thin layer that extends the common foundation, or we can also extend the default properties with some one-time configuration maybe. And if we think about what we had to define, filters and specific query parameters are naturally part of the API spec because in the API spec we define what we can use for filtering, so everything's already there. And if we have paging or not is also in the API spec because that's part of the interface. And what we could add is some mapping between the data model of the API and the data schema in the data platform. And on the more technical side, we could define a connection to the data platform within our Spring application configuration or also in the API spec with further extension fields. Configuration for paging, timeouts, stuff like that can also go to either sides of the picture. And with that, we have most of what we need to specify defined in code in the end. And in the end, you can choose whether you want to define it as a runtime configuration or you want to have statically in the API spec. And now getting back to the roads in Sweden, there is a real-world example for that actually. So I mentioned I was in Gothenburg. I took some pictures there. You see some roadworks going on, and you see roads in nice conditions. And the talk I gave is quite a bit inspired by current work that we are doing, and there is a project with Mercedes-Benz and Trafikverket in Sweden where they actually do exactly what I was mentioning. Mercedes-Benz vehicles capture data about the road conditions, and Mercedes-Benz is processing that data, makes that data available as a data platform, as data products via APIs, and Trafikverket in the end is using that data to know the state of the roads in Sweden and can plan the maintenance accordingly. And with that, I'm done. Tack så mycket.